Hi, so we can go ahead now and determine outliers from a residual box plot. And so the reason why we want to do a residual box plot is because recall that an outlier is when the distance from that line to the observed value is so large that it's much, much larger than any other distance from the observed into that line, so the residual. So that residual will be so large that it's considered an outlier. So right now the box plot, it will do is it'll calculate all those distances from the observed to the predicted value, and it'll calculate the box plot parameters, and then if a one distance is so large, it will turn up to be an outlier, like a little dot or asterisk on our box plot. And so prior to this, we looked for the residual plot to see if there was some sort of pattern. And if it had a pattern that was not a line, right, a curve, then we knew a linear model wasn't appropriate. And then now what we could do is use those same residuals and find whether or not there are any outliers by taking all those differences, right, those residuals, and put them in a box plot and see if there's a distance that's so large that it becomes an outlier on our box plot. We hope there isn't, because outliers mean we have to kind of adjust our data and stuff like that. So what we'll do is we'll go ahead and put our raw data in list 1, list 2, but then we'll have a third list somewhere where it will calculate our residuals. And then we'll go to stat plot and then go ahead and hit L3, and then we can do a zoom stat, right? So we could do a box plot. So this next example, we want to do actually a residual plot for the drilling time. And so we're going to comment on the appropriateness of the least squares regression model and produce a box plot of the residuals. So what we'll want to do is go ahead to go to your calculator and go to stat and go to edit and put all those drill times from that example that we did way back in 12.2 of the depth we started at drilling rock, and then how long in minutes did it take to drill 5 feet. And so I'm going to have to go ahead and plot a box plot and residual plot here. So now I'll go ahead and just clear list 3 out. Hit clear down. And I'll go ahead and do exactly what it says here. So my stuff is in L1 and L2. If you don't have the drilling data in your list, go ahead and pause the video and go ahead and re-enter them in. Then I will go ahead and L3, highlight L3, second list, and then pick resig and hit enter. So I highlighted list 3. I'm going to go to second stat and then go to resig number 8 and hit enter. Oh, but so the first thing we'll want to do is run a lin reg. So go to stat, edit, and I have my drilling times in list 1 and list 2. And so let me go ahead and clear list 3. And I'll put the residuals in list 3 like it says in the box. But first, I ran a lin reg test, remember, on the previous example of the 1,000 grams sample of radioactive material. So let me go ahead and quit this first. And then let me go to stat and let me run another lin reg, but on the correct data. So not L3 and L4. I want to go back and do it for L1 and L2. And then let me store the regression line, y vars, y vars 1, and then I'll pick 2 because I think the other one was the 1,000 gram. And then I can hit, so let me go ahead and drag this one over. Okay, and let me hit calculate. I'll put that right here. Great. And now let me go ahead and go to Stat and Edit and list 3. And now it's storing all those drill times and starting drill depths. And now let me highlight L3. I'll go to second list or second stat and hit number 8 and hit enter. And now it's going to give me those residuals. And again, what I just did was I took all the observed values and subtracted by the predicted values. So it grabbed this regression line over here, right, from the lin-reg. It put in every single x coordinate from the explanatory variable and put it in the line and calculated the predicted value. Then it took its observed rate at the same thing and found that distance, right? The calculator did all this work for us in like a second. And then it gave us a list of our residuals. Thankfully. So now these are the residuals for the drilling times back in that drilling example in 12.2. So I'm going to go ahead and drag this over, and then what I'll do is block out these. There we go. And so these would be the residuals. Okay, I think we're ready to start. We have it all set. Now what we can do is, the first thing we're going to do is go ahead and plot a residual plot. So go back to your calculator, and now we're going to go to stat plot. So second y equals, and we'll go ahead and put 1. And we'll go ahead and keep the residuals. And in this time, remember, we're doing X list is list 1. And my Y list will be L3. And let me go ahead and hit zoom stat. And it gives like this little scatter plot, right? And recall that because it doesn't make a distinct pattern, because it doesn't have a curve when we did it, right? Like because it doesn't have a curve or distinct pattern, that we would say that a linear model is appropriate. And then doesn't make a distinct pattern. Let me go to that previous example from the previous video right up here when we did the 1,000-gram radioactive material example, and we did the same type of residual plot, and it became a distinct pattern and a curve. So we knew that that set of data did not imply a linear model was appropriate. But when we did it here, notice it was no distinct pattern, no curve pattern, and therefore a linear model would be appropriate, which is good. Okay. And so the second part would be, now let's really make sure there are no outliers. So what we're going to be finding here is that whether or not we have outliers, right? And we're going to do this by a box plot of the residuals. And remember, we did residuals in L3 right here. So now we can go back to our calculator, go to stat plot, and I'll just use the same one that I've been using. But instead, when I go pick my plot, I'm going to go ahead and pick the box plot with outliers, which is the fourth one to the right, and hit enter. And so here, if we go back to this calculator box, it says that it wants us to put L3 in the X list. So we're going to put the residuals, instead of X1, we're going to put our residual list, which is L3, in there. So let me hit second 3, which will give me the L3, frequency 1, marker blue, now hit zoom 9. And it gives us this beautiful box plot. And why did I say it was beautiful? Because I don't see any outliers. So I think this is pretty cool. Um, so because this showed no outliers, that that we have a linear model with no outliers. So that drilling example that we did was totally appropriate. It had a strong correlation coefficient. It had a scatter plot that made those patterns as x increased, y increased. And now we're doing a residual plot. The residual plot showed no distinct pattern. That means the linear model was appropriate. And then now we're looking for outliers. So we did a box plot on the residuals and there were no outliers. So the drilling example is a perfect good example that a linear model, regression model is totally appropriate. However, again, in the previous example, when we did the 1,000 grams of radioactive material, we got a strong negative relationship, right? A strong line with this linear line in the data as x increased, y decreased, right? A nice pattern. But when we did the residual plot, it became a distinct pattern and therefore the linear model was not appropriate. So just kind of overview these last two examples, you'll see the difference between the drilling example and the radioactive material example.